So this is about electrolysis. So you need to understand some of the basic terms we use for electrolysis. You know about ionic compounds?
Yeah.
What do you remember about ionic compounds?
Ionic compounds, they basically help make elements and have a full outer shell. What else can I say about it? Ionic compounds.
Let me remind you.
They're group.
Ionic compounds are formed when a positive ion joins with a negative ion.
Yeah.
Like sodium combining with chlorine.
Yeah. And they don't conduct electricity because their ions can't move.
Okay, let me.
But wait.
Yeah.
It does conduct electricity when it's molten because the charged ions are free to move about.
Excellent. Ionic compounds conduct electricity in their molten state.
Yeah.
And also when they are in aqueous solution.
Yeah.
When they are in molten state or when they are in solution.
Yeah.
All right.
But I think covalent, they can't conduct electricity because I think it's because they don't have onboard charges, is it?
Yeah, because they don't have ions. Covalent compounds don't conduct electricity because they don't have free ions.
Yeah.
But ionic compounds conduct electricity in their molten state and also when they are in solution, when they are in aqueous solution.
Yeah.
But ionic compounds do not conduct electricity in their solid state. Did you hear that?
They don't conduct, in their solid state.
So solid sodium chloride, sodium chloride is an ionic compound.
Yeah.
Because it has sodium ion positive and chlorine ion negative. In fact, ionic compound is the bond between a metal and a non-metal. Sodium is a metal, chlorine is a non-metal. So the bond between them is.
And then covalent is the bond between a metal and a metal.
No, covalent is non-metal plus non-metal.
Oh yeah. And then that's metallic. Metallic is metal and metal.
Metallic is the bond between atoms in a metal. That's among atoms inside a particular metal. It's not necessarily one metal and another metal. It's not necessarily saying aluminium joining with iron. It's not necessarily what it's saying. Aluminium is a metal, iron is a metal.
Yeah.
So it's not necessarily saying aluminium and then iron. It's saying in the atoms inside a particular metal, like inside an aluminium.
Yeah.
The bonds inside the atoms, holding those atoms inside a particular metal is metallic bond. Okay. All right. But then, don't forget that ionic compounds can conduct electricity.
Yeah.
In their.
When they're molten.
It must be in molten or in
Yeah.
solution. So when they conduct electricity like that, that's when we talk about electrolysis. So repeat what I said.
Yeah.
So I said electrolysis is what happens when an electric current passes through a molten ionic compound. That's ionic compound that is in molten state, melted, right?
Yeah.
Or ionic compound that is in a solution, aqueous solution. And then the electric current will cause it to break down or cause it to decompose.
Okay.
It doesn't happen in covalent compounds because covalent compounds cannot conduct electricity. so they cannot undergo electrolysis. And don't forget that ionic compounds in solid state cannot also conduct electricity. Why don't they conduct electricity in their solid state?
Because the electrons aren't free to move.
They don't have free ions. Please read it properly.
Oh,
Explain. Say again. Why do ionic compounds not conduct electricity in their solid state?
their ions aren't free to move around.
Say that again. I'm underlining it. I expect you to read what I'm underlining. Why do ionic compounds not conduct electricity in their solid state?
Ionic compounds in their solid state cannot conduct electricity either, since they have no free ions that can move and carry their charge.
They don't have free ions that can carry the charge in their solid state. But in their liquid state, that's in their in solution. When they are in solution, when they are in what?
Solution.
The ions are separated, and so they are free to move.
Yeah.
Also, in their molten state, the ions are already separated, so they are free to move. Is that fine?
Yeah.
Okay. All right. So those are the things you need to understand about electrolysis before we even begin to talk about it in details. So for instance, we need to know what an electrode is. What's an electrode? Very quickly.
A rod of metal or graphite through which an electric current flows into or out of an electrolyte.
Okay. So the rod through which the current can flow through into or out of the electrolyte is a electrode.
Yeah.
You know. All right. Sorry, I need to move this up a bit so I can take it to the other side. Just a moment. I need to come. Okay. I need to reduce it a bit. Let it fit. Okay. For instance, look at this. See these rods?
Yeah.
These rods are the electrodes.
Yeah.
Current can flow through the wire into the rod and then enters into the electrolyte, which is the ionic compound in molten or aqueous state, and then flow into the other electrode and back to the battery or power source. So these rods are electrodes. These rods are electrodes, right?
Yeah.
The rod can be made of a metal or graphite. Now, electrolyte is the ionic compound itself
Yeah.
through which the electricity flows through. Remember that ionic compound can be in molten state or in aqueous solution.
Yeah.
Like in this particular example here, the diagram I have here, what is the electrolyte?
The molten zinc chloride.
Is the electrolyte. What's the electrode?
The anode and cathode.
What are the electrodes? Remember
Graphite.
the graphite.
Graphite anode.
Yeah, and of course you already know that the anode is the positive
Positive.
electrode, while the cathode is
And
the
the anodes attract the. Is it cation?
anode is the positive electrode.
Yeah, but then
They attract negative ions. They attract negative ions. So because they attract negative ions, pay attention so that you will get it properly. First of all, anode is what kind of electrode?
Positive.
And they attract what?
Negative ions.
And because they attract negative ions, those ions that are coming to the anode are called anions. or
Oh.
anode ions, or it's simply anode ions, which is anions.
Okay.
Cathodes are what?
Cathodes are negatively charged.
Negative electrodes,
Yeah,
the negative rod. So
and
what?
they attract.
They attract positive ions, is it not?
Yeah.
So positive ions which are attracted to the cathode are called cations, or in other words, cathode ions. I need to help you to remember it. It's easy to remember. The way you can remember it, you think of what ions go to the anode.
Anions.
Anions. And what is the charge of the ions that go to the anode again? Their charge.
What the ions?
Yes, they are charged. I mean, yes, they are anions. You are right. What's their charge? Negative, isn't it?
Yeah.
For instance, say it will be the chlorine that will go to the anode.
Yeah, because it's negatively charged.
Yes, while the zinc will go to the cathode. So the chlorine is the anion because it's going to the anode. While the zinc is the cation because it's going to the cathode. Opposites attract.
Yeah, I know this.
You know this, okay. I told you about half equations because you will apply it here. So zinc will lose 2 electrons, isn't it?
Yeah.
To become...
Positively charged.
No, zinc loses 2 electrons. Remember, zinc loses 2 electrons to become what? Zinc 2 plus.
Yeah. Yeah, so it's positively charged.
Yeah, chlorine will do what?
They would lose electrons.
No, chlorine
Oh, sorry, gain.
gain electrons to become 2Cl minus. Okay, so read what I wrote in black.
This circled ion will go to the cathode so as to receive 2 electrons and get discharged.
Okay, so this zinc 2 plus obviously will go to the cathode to get discharged. This Cl minus will go to the anode to also get discharged.
Yeah.
Go to the next page. I need to explain some things very quickly to you. All right. This is interesting. You need to take note of that. Reduction takes place at the anode. Reduction takes place at the cathode.
Yeah, okay.
Oxidation takes place at the anode.
Reduction takes place at cathode.
Remind me again, what is oxidation?
Oxidation is gain of oxygen, loss of electrons, loss of hydrogen.
In this case, only explain it in terms of electron transfer, because you will.
Oxidation is loss of electrons.
Oxidation is loss of electron.
Yeah.
Oxidation is loss of what?
Electrons.
So go back to the previous page so that you see how that plays out. So see this chlorine ion.
Yeah.
Is negatively charged, is it not?
Yeah.
For it to become discharged, it has to lose the electron. The excess electron it has. Did you hear what I said?
Yeah.
It has to throw away the excess electron it has.
Yes, so hasn't it been oxidized?
So it becomes oxidized at the anode.
Wait, can you repeat that? You broke up.
Oh, okay. Let me repeat what I said. Can you hear me now?
Yeah.
This chlorine is negatively charged, isn't it?
Yeah.
Remember, it is going to where? It's going to where? Did you hear me? It's going to the anode. to, by attraction, negatively charged ions go to the anode, isn't it?
Yeah.
And when it goes to the anode, it's going to throw away the electron so that it can be discharged. It has
Also, it's been reduced. It's gained.
It's going to lose electron. This chlorine will lose electron at the anode. That's what I'm saying. Simple way I can explain.
But in the next slide,
Speak properly. I need to hear you.
No.
I need to hear you better.
No, that's wrong.
You know, for the
I get that.
you get it now. For the chlorine, which has excess electron, to become just a normal chlorine molecule,
Yeah.
it has to throw away that electron. It throws away that electron at the anode, isn't it?
Yes, it's the oxygen.
So it loses electron at the anode. Is that correct?
Yeah.
That's why I told
Yeah, I
you
get that.
oxidation occurs at the anode. Go to the next page, you will see that again.
Yeah.
Oxidation occurs at the anode.
Yeah, oxygen takes us down. Oh.
If you think about reduction, what is reduction again?
Reduction is gain of electrons.
Reduction is gain.
The gain of electrons.
Let's think of sodium, this zinc here. This zinc,
Yeah.
what charge does it have?
It's been positive, so it's gonna.
It's going to collect electrons at the cathode, isn't it?
Yeah, it's gonna reduce. Reduction occurs at the cathode.
Yes, to become discharged and then reduced. So reduction occurs at the cathode.
Yeah.
It's a bit technical, but if you think deeply, you will understand that. I just need you to. I need to run through this table. This table is very, very interesting. Let me run through it.
Are
Because,
there reactivity series?
pardon?
The reactivity series.
Can you do what?
Are you on about the reactivity series?
Yes. There's something about reactivity series that.
Is it that when like I don't know, there's something about how hydrogen cases something.
No, reactivity series is about how elements are arranged in simple terms based on their
Based on the
ease of reaction or how easily they can react with other elements. In fact, potassium is more reactive than sodium. Sodium is more reactive than lithium. Lithium is more reactive than calcium. So as you go down, you need to be. Are you on the next page? I'm already discussing something on the next page.
Yeah, got it.
So as you go down, it becomes less reactive.
Yeah.
This reactivity series is important in helping us to understand something, particularly something higher than hydrogen and some other ones lower than hydrogen. For instance,
Yeah.
iron is more reactive than hydrogen, but copper is less reactive than hydrogen. Okay,
Yeah.
which one is the most reactive one in this list? From
Potassium.
potassium. Okay, you know, most of these precious metals like silver and gold are so unreactive. That's why they don't tarnish easily, they don't get oxidized easily. Copper, silver, gold, and they look virgin. In other words, they look they glitter because they don't easily get oxidized. They are not very reactive. That's why they are precious. They are precious metals.
Okay.
And that is going to explain something. In fact, let me say this before we move forward. Look at this. Go to the table. I want to use that table to explain something. Look at the first heading. The first one. What do we have there? Concentrated sodium chloride. Concentrated sodium chloride. When you have sodium chloride as the electrolyte. When you have what?
Yeah. Sodium chloride as an electrolyte.
Now it is concentrated sodium chloride. Concentrated means it is in a solution. It is what?
A solution.
We need to talk about the ions that are present. First of all, what are the ions present in sodium chloride alone? You have sodium ion and chlorine ion, right?
Chlorine. Yeah.
Now, the ions present in water, because it is in a solution, that's why it is. We talk about concentration or even diluted. The ion present in water are hydrogen ion and hydroxide ion.
Yeah.
Have you taken note of that?
Yeah.
Which ones are the negative ions here?
The hydrogen.
Negative.
The chlorine and the
Hydroxide.
hydroxide.
The chlorine and the hydroxide are the negative ones. Which ones are the positive ones?
The sodium and the hydrogen.
The sodium and hydrogen. Now, which ones will go to the anode? Remember, the anode is the positive electrode.
So chlorine and the hydroxide will go
Beautiful.
to
The chlorine and the hydroxide will go to the anode. Let me draw a circle around it so that you will see how that plays out. The chlorine and the hydroxide will go to the anode,
Yeah.
while the sodium and hydrogen ion will go to the cathode.
Yeah.
You see that?
Yeah.
But when they get to each of these electrodes, so one will be preferred and the other one will be dropped. That's what we call preferential discharge. Have you heard of that?
What do you mean?
One will be preferred, like one will be chosen, while the other one will be dropped.
Oh yeah, yeah, I've heard of that.
So I want to explain
Yeah.
that. Preferential discharge. One will be preferred, the other one will be dropped.
Yeah.
There are things that determine which one is preferred and which one is dropped. It's getting exciting. So I know it's getting exciting and of course technical. Okay, number one is their position on the reactivity series.
Wait, is this the one that's preferred?
Yes, that will determine which one will be discharged and then which one will be dropped, which one will not be discharged.
Yeah.
What we call preferential discharge. In fact, what I mean is, chlorine and hydroxide, chlorine and hydroxide ion, chlorine and hydroxide ion, two of them will all run to the anode, isn't it?
Yes.
But one will be dropped, one will be ignored, only one will be discharged. In fact, in this case, it's only chlorine that will be discharged, and I will tell you why. Also, sodium and hydrogen ion, both of them go to the cathode. Only hydrogen is discharged, sodium is dropped. Sodium is dropped. Why? And I want to explain it to you. There are a number of factors. One factor is their position in the reactivity series.
Yeah.
The ones that are lower in the reactivity series will be preferred.
Oh, okay.
Consider sodium and hydrogen. I mean, for metals, sodium and hydrogen, for metals, the ones that are lower will be preferred. For metals, so sodium and hydrogen, which one is lower in the reactivity series? Let's go to the reactivity series and prove that and see.
Sodium is even up there.
See the reactivity series.
Yeah, sodium's not there. Oh, sodium's higher. So
You can see sodium is higher than hydrogen. Hydrogen is lower. So hydrogen is lower in the reactivity series, so it will be preferred, and sodium will be dropped. That's why hydrogen will be discharged and sodium will be abandoned, will be ignored.
Yeah.
Is that clear?
Yeah.
So one factor is position in reactivity series.
Yeah.
That's one of the factors that determines which one is chosen and which one is ignored.
Yeah.
All right. Can you remind me of one factor that determines which one is chosen and which one is ignored?
The position of the reactivity series. So
Oh.
the lower it is, the more
Accepted, the one that will be preferred. The lower one will be preferred, the higher one will be dropped or ignored.
Yeah.
And that is why even when both sodium and hydrogen, both of them went to the cathode to be discharged, sodium was ignored while hydrogen was preferred.
Yeah.
Now there's also another factor. I'm going to write that down later. Another factor is concentration. What do I call that? What did I say?
Concentration.
The ones that are more in number. What did he say here?
More in number.
Yeah, like he says concentrated sodium chloride. Concentrated what?
Sodium chloride.
Means you have so much chlorine than hydroxide. Because
So
it's
it's concentrated more
like concentrated means there's more of it than water. You know, when you have concentrated drinks, it has so much of the content than water. If it is diluted, it has so much water.
Yeah.
So concentrated sodium chloride means it has a lot of chlorine than hydroxide, isn't it?
Yeah. So is it like?
The more concentrated will be discharged. So chlorine will be preferred. That's why at the anode, we know chlorine ion and hydroxide ion, both of them come to the anode. But which is chlorine that was chosen? And why was chlorine chosen? Because there's so much of chlorine.
Oh yeah, it's concentrated. Yeah.
It's concentrated, so chlorine is chosen. I've mentioned two things that determine which one is chosen. What are the two things?
The position, the reactivity series. So the lower,
Yes, the position in the reactivity series. For metals, the lower one in the reactivity series will be preferred. Like hydrogen was preferred at the cathode, whilst sodium was ignored.
Yeah. So
Another-
and the concentrated, because there's more of it, it's not preferred. So
Yes.
that's why chlorine is preferred in that one.
Exactly. Now, when these ones go to these two ions, chlorine and hydroxide, go to the anode, because it is a concentrated sodium chloride.
Yeah.
That would be different if it was dilute. You know, that's how. You see, when we come to dilute, you're going to see a different thing. And so you better pay attention to this. Concentrated.
It's dilute, like.
Dilute means there's so much water.
Oh, yeah, dilute.
In fact, look at it here, so that I don't have to waste time. Look at dilute. Look at dilute. Check the ones that came to the anode. Same chlorine and chlorine and hydroxide, isn't it?
Yeah.
But which one was discharged?
The hydroxide.
You know why hydroxide was preferred for dilute? Because dilute means it has so much water, and inside the water there's so much hydroxide.
No, does that?
The two ions that also went to the anode are
Chlorine and hydroxide.
which one was discharged? If you look at the equation,
So, for the first one it's chlorine because it has more concentration.
there's so much
The
of
second one,
chlorine because it's a concentrated sodium chloride, so much of chlorine. But when it comes, in the second one it is hydroxide,
because it's dilute, so there's a lot of it.
a lot of it. But when we come to the metal, when we come to the metallic ion, the positive ones, sorry, let me call it positive ions. Positive ions.
Yeah.
Positive ions, it is usually its position in the reactivity series. Is usually is what?
Position in the reactivity series.
Is positioned in the reactivity series.
Yeah.
So sodium and hydrogen, which one is lower in the reactivity series?
Hydrogen.
Hydrogen. That's why hydrogen is preferred.
The preferred one. Yeah.
That's why hydrogen was preferred, discharged. I just want to show you something. Look at this one that has copper in it.
Where?
Look at this one I'm circling here.
Yeah. Concentrated aqueous copper sulfate.
Okay, first of all, from the copper sulfate, what are the ions from the copper sulfate? You have copper 2 and you have sulfate. What are the ions from water?
Yeah. Hydrogen and hydroxide.
You have hydrogen and hydroxide. Okay, so which, these ones I'm circling in blue, we go to where? Anode or cathode?
Those will go to the cathode.
Cathode. They will go to the cathode because the cathode is the negative plate. So, but check out which one was discharged based on the equation we have here.
Which one is
Between copper and hydrogen, which one was discharged?
It was hydrogen.
You see what I'm circling?
Sorry.
You should be looking at what I'm circling.
No, I thought you meant in the concentrated, like.
No, I'm you know where I am. So which one? The equation tells you which one was discharged. So which one was discharged here?
The copper.
Copper.
It's lower down in the reactivity series.
You know why copper was discharged? If you check the reactivity series, you see that copper is lower.
Higher, yeah.
So let me take it down to show you. See hydrogen, see copper. Copper is lower than hydrogen,
Yeah.
so it's discharged, preferentially discharged. So it is discharged and then hydrogen is left
Yeah.
behind. If you understand this, you've understood electrolysis.
Yeah.
You just
I get this.
treat
Basically, just know the preferred thing.
that's all. All that you need to know is how to write the half equations. We've already done half equations.
Yeah, we've done that, yeah.
You need to, in fact, I will actually ask you to memorize the half equation when hydroxide is involved.
Oh.
Read it out. What I'm circling
4OH minus
gives
O2 plus 2H.
plus 4E. 4E minus. Since it gives O2, it means oxygen will be released. Oxygen gas will be released, isn't it?
Yeah.
Go up there and see for the chlorine. See, I'm circling it. Read the half equation for the chlorine.
2Cl minus Cl2 plus 2E minus.
So since Cl2 is discharged, it means chlorine gas is released, right?
Yeah.
Because sometimes they will ask you which gas is released at the anode. If you write the half equation, you will know it is chlorine that is released there. Look, read this equation here.
2H plus 2E minus H2.
Okay, so which gas is released here in this one I'm circling?
Hydrogen.
Hydrogen, okay. All right. So this is how we analyze electrolysis.